And we're going to move our prism into the beam, and you'll see it as it refracts through the prism. As we change the angle, you'll notice that the refracted beam has a different angle of deviation. The goal for this part of the activity is to find that minimum angle of deviation. When I move the prism into place, you can see the deviated beam being refracted through the prism and striking the projection screen over here. There's about the minimum right there. And so we're trying to locate that minimum point. So I'm going to say the minimum is right about there. Derek, now you can move that prism off of the paper, and we'll start off by verifying the angle of the prism, the apex there, what the book calls angle A, and looks like sure enough, as we expected, it's 30, 40, 50, 60 degrees. Okay, so now that angle of deviation is going to be the angle that the deviated beam makes with the incident beam. So we can find that point of intersection, and then we'll place the protractor right so that the vertex is right on that point of intersection. And now let's measure that angle at 0, 10, 20, 30, and what do we have there, Derek?
We have 35, 36, right about 37 degrees.
37 degrees. So our angle of deviation is 37 degrees for delta. We can put that into our formula that says the sine of the sum of the angle of our prism plus the minimum angle of deviation divided by 2, divided by the sine of that angle of the prism divided by 2. So that would be 60 plus 37 divided by 2, and the sine of just 60 divided by 2 comes out to an index of refraction calculation of 1.498, or very, very close to 1.5, which is probably what the index of refraction is for this prism.